Economic analysis. One of the main things we are focused on as a country is the state of our economy. Economics is the study of the production, distribution, and consumption of goods and services. As a country, we are always changing and adapting to the world around us, and it is important to stay informed on where we stand as a whole and as well on a micro level. Mathematics has become such a large part of economics because it helps form quantifiable data. This paper first discusses the fundamentals of probability and statistics in economic analysis, then goes on to explain forecasting trends and predictive modeling, and finally the introduction of big data and how it has impacted economic data analysis. It is very important to summarize observed economic data in a simple, intuitive, and interpretable way as to convey information to economists, decision makers, and the public. With our society rapidly changing and implementing technology at every level, understanding all of that data is just as important or even more. Probability and statistics are used to summarize, model, and analyze data for economics. The most basic and first use of mathematics in economics is the use of descriptive statistics. Descriptive statistics summarize datasets into measures of central tendencies such as mean, median, mode, and measures of variability such as standard deviation and variance. Descriptive statistics also measure the frequency distribution, which counts the occurrence of different variables in a dataset. Specific examples for descriptive statistics used in economics would be the average income in a household or the average of an individual's education, which in turn results in the creation of more specialty jobs. Within economics, there are constant rippling effects from any small change in the larger scheme of big data to build off of the last point with an increase of specialty jobs in a certain region can overall bring business and increase the nation's GDP. With the emergence and ease of access to technology in the mid-19th century, those specialty jobs become more and more needed, especially in higher GDP per capita countries. These jobs brought revenue and gave all this big data highway to run through, being filtered and used. Those countries that lack the infrastructure or resources experience little or slow growth because of it. This use of descriptive statistics is great to input into a graph that can make data easier to visualize. Companies and businesses use all sorts of graphs such as bar graphs, pie charts, and line graphs to help them visualize trends happening in their data collected. These graphs can be helpful for making decisions in day-to-day operations or on a larger long-term scale. Descriptive statistics can be split into multiple categories: univariate, bivariate, and multivariate. Univariate data analyzes one variable, bivariate data analyzes the relationship between two variables, and multivariate data analyzes the relationship between more than two variables. With bivariate and multivariate data, we can do simple and multiple linear regression. In simple linear regression, we analyze the relationship between one output, an independent variable, and an output dependent variable. The formula of simple linear regression is given in slope-intercept form. Using simple linear regression shows us the strength of the relationship between the input and output variables and the value of the dependent variable given at a certain point of the independent variable. Multiple assumptions about the data need to be met for simple linear regression, including homoscedasticity, independence of observations, normal distribution, and linearity. Multiple linear regression is very similar to simple linear regression, but instead it analyzes the relationship between two or more independent variables and one dependent variable. The formula for multiple linear regression is shown. For multiple linear regression, it is important to find the best fit line for the different independent variables used in a particular study. This is analyzed through the outputs given from a multiple linear regression. The standard error shows how much variation is in the estimates of the regression coefficients. The test statistic displays the t-value from a two-sided t-test. The larger, the greater confidence in our coefficient. The p-value given tells us whether we accept or reject our null hypothesis. The lower p-value is more likely to reject the null hypothesis and conclude the relationship between the variables. Multiple linear regression is a great tool for economists and can easily be coded and given outputs to analyze multiple variables. An image is shown of sample of code output for multiple linear regression. The graph will then calculate the t-statistic and p-value for each regression coefficient in the model. Through formulas and programs, these large amounts of data can be analyzed effectively and efficiently. Economics and mathematics have the ability to go hand in hand, showing just what is capable of the human mind working with technology. An example of a regression model used in economics would be the relationship between years of education, hours worked in a week, and household income in a specific town. From this model, they can quantify the relationship between the variables and see at what rate household income increases or decreases as years of education and hours worked in a week change. Another being years of higher education in relation to annual income. If an extra year of education resulted in a $20,000 year increase in earnings, then many more people would take advantage of that example, with the counter argument being if an extra year only resulted in a $50 a year increase, that extra investment in time would not be worth it. Another important way that statistics is used in economics is in the way of economic forecasting. Economic forecasting is the process of collecting data and then trying to predict through analysis the future state of our economy. On a smaller scale, companies and businesses can create a forecast for their future sales by using data over past years. On a larger scale, forecasting can be used to identify indicators as a nation. Companies and businesses can rely on these indicators to make decisions for investments, spending, hiring, and other important decisions. Economic indicators are measures usually on a macroeconomic scale that can be used to measure and evaluate the state of economic activity. There are various types of indicators used by economists, investors, companies, etc., that categorize into three groups: leading, lagging, and coincident indicators. Leading indicators are measurements of possible change in the future economy, such as the yield curve, Purchasing Managers Index (PMI), or the Consumer Confidence Index (CCI). The yield curve is a line that plots the interest rates of bonds throughout a range of maturities. When the yield curve displays a normal curve, that infers the economy is stable, and if the curve is inverted, it can correspond to a period of economic recession. The Purchasing Managers Index (PMI) is an index that measures economic trends in manufacturing and service industries. The PMI is collected by the Institute for Supply Management (ISM), which collects data from over 400 purchasing executives in the manufacturing sector, representing 20 industries, corresponding to their contribution to the gross domestic product (GDP) in all 50 states. If the PMI is over 50, it represents growth within manufacturing of the economy, and a reading under 50 represents contraction within the economy. Lagging indicators are output measurements of something that has already taken place, such as the unemployment rate, gross domestic product (GDP), or the Consumer Price Index (CPI). The unemployment rate represents the number of unemployed people as a percentage of the labor force. The rate can be determined by using the formula unemployment equals unemployed divided by labor force times 100. The gross domestic product (GDP) measures the monetary value of the goods and services produced in a specific country. The GDP can be determined by using this formula: private consumption plus gross private investment plus government spending plus exports minus imports. The Consumer Price Index (CPI) measures the overall change in consumer prices based on a representative basket of goods and services over time. The rate can be determined by using this formula: cost of the market basket in year T divided by cost of the same market basket in the base year times 100. Coincident indicators are measurements that show activity in a given business cycle, such as the rate of industrial production or sales of manufacturers, wholesalers, and retailers. With the huge growth of the internet in the past 30 years, data has become readily available and abundant. Every click you make on the internet is tracked and logged, and almost every aspect of our lives, like messaging and calling, personal finances, or health records, are recorded. Having such a vast amount of data can have its difficulties of being unstructured and too complex. With this newfound growth of data has come new ways to analyze and predict economic activity. One important way is predictive modeling. In a predictive modeling problem, there can be n possible entries that are associated with n outcome measurements and a set of k potential predictors. The possible number of potential predictors, k, can be larger than n. Although the out-of-sample performances may be poor when this occurs, so we want to maximize in-sample predictive power. These predictive models can be great statistical models for economists, so they can better understand the large amounts of data they can handle. To conclude, statistics, probability plays a great role in our economy. It can be used to summarize, model, and analyze various variables with large amounts of data. From as simple as descriptive statistics, such as means and measures of variability, to forecasting trends and predictive modeling, statistics gives us a great advantage. With the introduction of big data and advances in data analysis, economists are able to draw conclusions that we have never been able to. Statistics and probability used in data analysis is helping us to better analyze and predict the outcomes in our economy. Thank you.